Okay, so now we're going to go ahead and look at special relationships between lines. And this is something that's going to follow you into geometry and beyond. And the first thing we're going to talk about is parallel lines. Now, parallel lines are lines that will never intersect each other. They're in the same plane, but they just run totally parallel to each other. So they run side by side, so they never ever touch. So the symbol you need to know for parallel can look like this or like this, depending on what typing program someone has or how they tend to write. And they never intersect. In order for lines to never intersect, they have to have the same rate of change or the same slope. So we can tell if lines are parallel by graphing them and looking at them, or we could tell just by looking at the equation of the line and seeing if they have the same slope. So in my first equation here, I have y equals 2x plus 2. My slope is 2 on that line. What I'm going to do now is I'm going to take a look at my second line, and I want to see if this has the same slope. So I have 4x minus 2y equals 10. So we've talked about this before. We're going to move the x to the other side. So that cancels out. I'm left with negative 2y equals, now remember these are not like terms, so they cannot combine. So this is negative 4x plus 10. And then I divide everything by negative 2. That's going to get rid of the 2 and the negative, so now I have just y. And then over here, the negatives cancel. 4 divided by 2 is 2. And then 10 divided by negative 2 is negative 5. So now I'm comparing the slope of my first line to the slope of my second line. And I want to know, are they the same? And yes, they are. They're the same slope. So the lines are parallel. Okay, so we're going to look at our next one. Y equals negative 3x minus 5. So here's my slope, the negative 3. And now I've got to go ahead and check my next line. So I'm going to go ahead, I've got 2y minus 6x equals 2. So I need to solve for y, so I'm going to move my x to the other side. So I'm going to add 6x. So now I have 2y equals 6x plus 2. I divide everything by 2. So the 2's cancel, and I get y equals 6 divided by 2 becomes 3x. 2 divided by 2 becomes 1. So now I'm comparing these slopes. And I want to know, are they the same? Well, they're the same number 3, but not the same sign. So they're not the same slope. So if they're not the same slope, they are not parallel. Okay, and our last example for this slide, we have y equals 4. So the first thing we have to figure out is what is the slope. So usually for slope we look at what's next to the x, but there is no x. So this is really y equals, there's no x plus 4, which means my slope is 0. Now I'm going to compare over to here. Y equals 2x plus 4. So 2 is my slope. Still not the same. So not the same slope, not parallel. Just because they both had 4's in them did not mean that they had the same slope. Okay, so now we have another case that we're going to talk about. And these are perpendicular lines. Now, perpendicular lines are lines that intersect to form 90-degree angles. And they're also known as right angles. They kind of look like this. That's a 90-degree angle. We typically put a box in it to indicate that it's a right angle or a 90-degree angle. So when we look at perpendicular lines, they're going to be lines that would cross like this, or even cross like this, so that way this is really a 90-degree angle. So they're crossing, and they're crossing in such a way that all those angles that they're creating there are 90 degrees, which is really important because in geometry, construction, and stuff like that, 90-degree angles are what we base everything off of. We like everything to be straight up and down at that 90 degree with the ground. So how do we determine if they are perpendicular? If they are perpendicular, you've got two options. You can multiply the two slopes, and if the answer is -1, then they're perpendicular. The way most people like to do this, though, is we can recognize them as opposite reciprocals, which is a flipped fraction and opposite signs. For example, 2 over 1, whoa, why is that all weird? So 2 over 1, if I were to flip it and change the sign, these are what we call opposite reciprocals. These would be perpendicular. Or 2/3, I could flip it and change the sign. Or we could have -1. So I have to turn it into a fraction first. So I put it -1 over 1. I can flip it and change the sign. So -1 and actually +1 are opposite reciprocals. Because when you look at that first fraction, it's really the number -1. Look at the second fraction, it's actually the number +1. Okay, so now what we're going to do is, now that we have a whole nother idea, we've got perpendicular, we have parallel, now we have the ability to determine if any lines are parallel, perpendicular, or none of the above. So if I look at my first question here, y equals 3x minus 1. So I'm looking at my slope here, 3. And now I've got to take the second equation, I've got to solve for y so I can figure out my slope. So I'm minus 3x on both sides. So I get y equals -3x plus 5. And so I have 3, -3. So I've got 3 and -3. So, are they parallel? No, not the same. And then when they're not parallel, we can take that parallel sign and I can draw a line through it saying, nope, not parallel. Okay, the next thing we're going to do is we're going to check and see if they're perpendicular. So I'm going to take that 3 for that first slope, I'm going to put it over 1, I'm going to flip it and change the sign. Is this the slope over here? No. So not opposite reciprocals. So not perpendicular. And then the symbol we use for perpendicular actually looks like this. It looks like two perpendicular lines. So that means our answer is neither. They're not parallel, they're not perpendicular, so this is neither. Okay, next one. My slope here is 5. So now I'm going to check the slope over here. So the first thing we're going to do is I'm going to get my y by itself, so I move x. So now I have 5y equals -1x plus 2. Remember, those can't combine. I divide everything by 5. So now I have y equals -1/5 x plus 2/5. And now I have to compare this slope to this. So they're not the same, so they're not parallel. Got to check perpendicular. So I take the first one, 5 over 1. If I flip it and change the sign, does this match my second slope? And yes, it does. They're opposite reciprocals, so they are perpendicular. And I really like having those symbols for like parallel and perpendicular because it gets annoying to write out the words and they're hard to spell. So if you know the symbol, you can use that correctly, but you can't use the symbol if you don't know what it stands for. So either you spell out the word or you use the symbol. Okay, so now we're going to take that a step forward. We're going to kind of go back to the idea we know about parallel, we know about perpendicular. Now we're going to go back to writing equations using this idea of parallel and perpendicular. So I want to write the equation of the line that goes through the point 4, -1 and is parallel to this line. So if it's parallel to this line, my slope should be the exact same as the slope of that line. So what is the slope of y equals 2x minus 7? Well, my slope is 2. So over here, my slope is going to be 2. My point is 4, -1. Now I can write the equation of my line. So y minus the y value of my point equals m times x minus the x value of my point. I take care of my double negatives, and there's my equation. Now, if I wanted you to rewrite it in slope-intercept form, then you would have to multiply inside. So this would turn into y plus 1 equals, now 2 times x is 2x, 2 times -4 is -8, and then I move the 1 over. So y equals 2x minus 9. So pay attention to the directions, because you don't want to have to go through all that work if you don't have to. Now that we've kind of talked about that, we're just going to go ahead and write our equations in point-slope form. Okay, so write the equation of the line that goes through the point, -6, 2, and is parallel to this line. So remember, parallel means the same slope. So I'm going to come to this line and I'm going to grab the slope. I totally ignore everything else about that. All I need is the slope. So my slope is -3/2. My point is -6, 2. And now I can write the equation of my line. So y minus the y value of my point equals my slope times x minus the x value of my point. I take care of my double negatives, and I'm good to go if I want point-slope form. But because I like having lots of examples for you, I'm going to also show you how to write it in slope-intercept form. So I distribute the -3/2. So this is y minus 2 equals -3/2 x. Now when I multiply, I'm going to multiply -3 times 6, which is -18. And then I keep that over 2, and now I divide out. 18 divided by 2. So y minus 2 equals -3/2 x. -18 divided by 2 is -9. And now I move that 2 over. So y equals -3/2 x minus 7. And again, our last example I showed you in slope-intercept form, mainly because it was pretty easy because my slope was only a whole number. But here I wanted to give you another example of doing that slope multiplying with the fraction. Just because the more you see it, the more you practice it, the better you get at it. And it's less fearful that way. Okay, write the equation of a line that goes through the point 4, -1 and is perpendicular to the line y equals 2x minus 7. So for perpendicular, I want that opposite reciprocal. So I'm going to come to my line, I'm going to take that slope, 2 over 1, and I'm going to find the opposite reciprocal. So I flip it, change the sign, and that's the slope I'm going to use. So now I'm going to do y minus the y value of my point equals this new slope times x minus the x value of my point. I'm going to go ahead and take care of those double negatives, and I'm just going to leave it there because I've already showed you, we've done it enough. I don't need to show you again how to do that slope-intercept form. So there's our answer in point-slope form. Good to go. Okay, write the equation on a line that goes through the point -6, 2 and is perpendicular to the line y equals -3/2 x plus 11. So I'm going to find my slope. negative 3/2. And for perpendicular, I flip it and change the sign. So now I change it to positive. So this is my new slope I'm going to use. So now I'm going to do y minus the y value of my point equals my new slope, 2/3, times x minus the x value of my point. I take care of my double negatives. And as long as they want it in point slope form, we're good. So read your directions. Look, point slope form or slope intercept form. If they want slope intercept form, you start with point slope form and then you do your distribution and you'll be fine.